Hello, ladies and gentlemen. Thanks for joining my online presentation about the Opto products. Today I'm very proud to present you the new imaging module software and especially about how to deal with artificial intelligence here. So we are the guys to automate microscopy. Opto produces intelligent digital microscopes and vision sensors. That's what we are doing since the last 40 years. So now we are bringing them really into sensors and artificial intelligence for medtech applications in standard and custom versions. What is our target? Our target is to address machine builders and system integrators, very much in the biomed industry, where it's about screening, PCR screening, point of care testing. So, and everywhere where you're thinking about this, the things have to be small, the things have to be cheaper, and that's what we are invented, so to say, the imaging modules. Since 40 years, we're doing optic, camera, illumination, special contrast technologies that we are incubating now in a standard product that would be called imaging modules. So we're starting, so to say, at a field of view about 10 by 10, 50 by 50 millimeters and going down to micron and nanometer resolution. And that's what we call imaging modules. In a standard form factor, so the idea was really to do microscopes in a very, very small form factor like this one. And the intention was really to do something like the guys doing with the smartphones, having a USB key and then driving all the functions. And then together with the know-how that we acquired over the years in doing this in volumes, we really created two platforms, a hardware platform and a software platform. And more this software comes into the job applications. And here we call it job modules later on that are then really doing an application therefore. So digital microscopes and vision sensors, that's what everything is all about. So, and what is an imaging module? So we are incubating nearly every type of cameras on the board level. So we are not a camera manufacturer, but we're an integrator of board level cameras. So we're making our own electronics. We are making our own connectors. So the idea is to have principally a single wire application, to have as less cables away from the device, especially for integrators. As we are coming out of the optics industry, microscopy, we have many optical designs in-house that we are incubating with own manufactured boards. We are doing own LEDs, especially in fluorescence. We have a big know-how, and then again, with the different form factors and the software, you will get many hundreds of imaging modules later on, and that's what we are publishing throughout the audience right now. So what I had in my hand and what everybody see here is a pure digital microscope. It's a pure digital microscope. So what you know from Leica's size in this compact form factor. And that's what we are going to do here. So we're having this camera, we're having a beam splitter inside for incident light. We have a mirror, we have an objective, we have a tube lens, everything that a normal microscope has, plus also a ring light. So we have dark field, we have bright field illumination in this small form factor with a very easy to use interface. The idea was not to have a camera, to have this, have three wires, only have one cable away. You don't have maybe one or two suppliers, you have only one supplier. So normally if you have so many features to take care of, also many things can go wrong. So that's what we are trying, one module for one application. So that's how it's mounted on a stand. So you see the small footprint in microscopy. So we have field of views only about some millimeters, but with micron resolution and with a dark field illumination like a ring light, you can highlight, so to say, the scratches on your surfaces in the semiconductor industry. It's the images on the right side where bond wires are inspected with coax. It's perfect to see the features. Small ball bearings where you see features that you principally can't see in one illumination. So you have to have a second, and more or less when we're adding color to it, and that's how you see how all these features, all these many imaging modules coming together. You even see polarization effects for metallography and others. To calibrate these things, so they are pre-calibrated, so normally no calibration is necessary, but for us to show the customers how to compare with an existing microscope or an existing setup, we make our own calibration targets or particle targets here up to 1,200 line pairs per millimeter. And now, so say, where is the market going? So we are going for the next generation ideas to fuel it with 2 cameras to substitute all the zoom markets, and more in microscopy in medical fields. We having here multi-fluorescence platforms where we can go for pathology, qPCR screening, or electrophoresis applications, where we have in this module 2 separate fluorescences that we can switch in milliseconds. So completely unique. Here you see the setups. So on the right side, 2 LEDs, the special filters, so you can switch between 2 very narrow or fitting fluorescences, or we have 2 sensors with a form factor with a magnification change of about 4, all with 5 megapixel sensors at that moment, IMX264 sensors integrated, so we have principally a perfect image. More and more we are going to these screening applications where we are about blood screening, where we are about urine screening. Microfluidic applications are a big factor, and therefore we defined this profile form factor where we have a complete microscope on the one side and also a condenser on the other side, but purely for machine integration. And you see the size, so it's only 40 millimeters in depth. It's 200 millimeters by 140, so a really nice shape that you can build in every machine, coming with USB, also having the option in gigabit Ethernet. So that's what we are wanting to do. And based on this modularity in hardware, we are adding modularity in software. We're designing our software with an own software team. It's a huge platform for going into these job applications, for more and more bringing the lab equipment that you see on the left side really to automation, to digital microscopy, predictive diagnostics. So microfluidic is a big part of ours. So we are screening cells, or we are making a blob analysis working, where we have hundreds or thousands of frames per second, tracking a small flow, making images of a particle, or here a pollen, to make really 3-dimensional rendering, because we are believing that morphology is coming more and more into account to take care about making diagnosis about diseases. So here you see these multi fluorescence platforms where we have up to 12 fluorescences in some seconds, doing to then create, so to say, PCR screening, quantitative digital screening, the implementation into robotic applications, or in applications where you can't move your sample, we're moving the microscope. That's everything about automation of microscopy, digital microscopy, so up to complete lab automation for screening, building the software to go to artificial intelligence, because the key for artificial intelligence is reliable images, always the same images, not the absolute performance, but data analysis, data mining makes it really a strong put. So at the end, one perfect module for one application. So that's the epic questions. Okay, we want to be the glue between photonics and machine vision. And so thanks for your attention. And please feel free to visit our booth or to ask me in the chat.